All here now, right? So I actually started recording. So if everybody's ready to go, we can start.
Cool.
Are we good? Okay.
Fantastic.
Good.
Okay. Did everybody get the first two questions done?
I think so, yeah. Let's see here.
Your data, null hypothesis is, and hypothesis generation is Jordan collects the sample data of computes. Okay, so are we ready for the question number 3?
Yep.
Yes?
Yep.
Okay, so I'm not reading through, I mean, everybody's looking at it. It just, after it states everything, it says Jordan collects a sample size of 9, computes is that the mean at 2.2 and the standard deviation at 3.3?
The difference.
The difference is 2.2 and the standard deviation is 3.3. Okay. Okay, so what's the value of the test statistic? They just ask us one of these. Or
Two.
Is it?
It's 2.
Is it just 2? Now, what was?
You know, I just know it's 2 because
Thanks,
I
Ben.
always do the first try before we come to group meeting. I'm not gonna lie.
I sensed you did, Ben. Okay.
Yeah.
That's awesome.
So,
That's all right.
So this is my second try. I just know it's 2.
Okay.
Going through it. So I mean,
Thank you.
This part is definitely it's getting pretty interesting. Well, let me tell you. Monday stuff or this week's stuff, and I've already taken Wednesday stuff too, just once.
Right.
And
Yeah.
I'll retake it Wednesday with you guys. But today's stuff is a little bit better. It gets crazy on Wednesday a little bit. I mean, it just seems like they throw a little more action into it to make it more spicy, I guess, so to speak. But yeah, it's 2. And how I got there, I think just go in and putting all the information into that deviation,
right, and then
the
just
quantitative inference, or the inference stuff, and then going from there.
And honestly, sometimes it's like the spreadsheets. If you have to just plug it in and go, okay, there's the answer. Okay, I'm not sure how, but I know that's the right answer. Okay.
Exactly.
Okay.
And
Perfect.
for number 4, I know it's not 0.969. Other than that, I don't know what it is.
Okay, the probability of obtaining a test statistic greater than Jordan's test statistic is 0.04. Uses probability to determine the p-value.
Yeah, this one's weird. I don't know if you guys have been having the same issue, but I plug in all those numbers exactly, and some of the numbers just are not jiving. And just to check it, I'll check Chegg or Course Hero to see, what some of the online tutors or what are doing. Right. Chegg is better because Chegg, they'll actually show the work. Like, well, if you get a good tutor, and then they'll put the work on there for you, and then and it shows you how to get there. But for some reason, I don't know. It's just the p-value when I put it in as 0.969. It's not it.
It's not.
And that's what I got when I plugged all the numbers in to the quantitative inference table.
0.969. Does anybody else try it? Anybody else tried it and see if they come up with something different? And it's not dividing the p-value in half, is it? Because they're sometimes dependent on the test.
It could be. I'm not sure.
Because you know how if it's I put in a little note in one of my things that said if it's a single or whatever. Anyway, you actually have to divide it in half.
Right. If it's a single side, it has to be divided in half.
Right. So I didn't know if that would be the case. I wouldn't know if it's a single. Would we know that? This is collects a sample size of. Okay. Is anybody else? Rod, did you figure anything else out?
It's not a significant sample size either, right? It's only 9 or something in the sample size.
Sample size is small. It's 9, but that's regardless, right?
We're on 4, right? I was just trying to figure out number 4. I got 0.081.
You got 0.0, and how did you get 0.081?
Oh, let me find my.
Yeah, I'm pulling up the A1 and the B1 charts now. I have them on my downloads. I thought.
Yeah. Okay. So
I was just gonna plug in my numbers and try to figure something out.
You see my screen?
oh wait.
Can I see your screen? No. There you go. I'm looking at it now.
So we got the 8 in here from
The 8 degrees.
9 minus 1. You get the 8. Oops.
Where did you get the Z number? Then how do you get the T number? Oh, the T number, which is the 2. You put in the 2,
Yeah, the 2's from question 3.
and then you got the degrees of freedom, which we can get off that. Wait, does it say the degrees of freedom?
No,
How did you get the degrees of freedom then?
It's usually the number.
The sample size and the
minus 1. So that's where we got the 8. That's where I got the 8.
The sample
Oh,
size, yeah, n equals 9, then you minus the 1.
okay.
And it's not equal to, so you shade both sides and you get 0.0805, and it rounds to 0.081.
Okay, sounds good to me. How about everybody else?
Yeah,
Okay.
sounds good to me. I'll just watch the video after it's done, just to kind of.
Mhm.
And that's another thing too. I've kind of failed in the past to do is I need to start looking at the other groups' videos too, because perhaps maybe they're taking a different angle than we have in the past to kind of understand it a little better or something.
Okay. I never thought about watching everybody else's videos. I,
Yeah.
watched theirs. Okay.
Yeah, I was thinking about it today because I was hitting my head. I was like, I was ready to blow my brains out because Wednesday stuff is more interesting, and it's just like, I wish the video, that guy. First of all, he needs a mic. He does a good job, but I mean, if you're gonna have a professional online program, you need to have a mic, and you need to, you need to cover all the stuff that is covered, whether it be in the test or the homework. Go over the problems, because that's what they did in algebra. They went over it several times, and they kind of took it at different angles. Why wouldn't you do that in statistics? So I don't know. That's just me.
Well, I think it seems like he speeds through the videos pretty quick. I have to stop and reverse about 100 times just to kind of get through it.
Yeah, the guy that does it in the classroom, his videos are definitely better than the other guy that just looks at his computer screen and talks and doesn't do anything.
Yeah, right.
But still, I mean, I don't know.
Maybe he'll watch this and see the error of his ways.
Yeah, I don't know. Something tells me he's not there anymore. I don't know, because that stuff. Those videos we recorded it back in 2013, so that's 5 years ago.
Yep.
But anyways, go ahead. I don't want to hold anyone up. We'll figure it out some way or another.
Okay, so we need the chapter. I'm trying to figure out what the chapter one. Oh, it's chapter A. Okay, so we're looking at. We need to use the A1 stuff. So I'm just going to plug it in.
Yeah, the test statistic is. Hold on.
And we're plugging it into just the difference. Oh, do we have to figure out the difference before we copy it over?
What are you talking about? Are you talking about the
Okay, so we're on the next question. We've
for
got
5?
use,
Oh, yeah. Yeah, you copy that information and put it in the quantitative.
But
yes.
we want to get the difference before we copy it, right?
It's 0.407, just to let you know.
Okay.
If anyone wanted to know the answer, just throwing that out there.
0.407.
Mm-hmm.
All right, well, I can just not copy and paste it then. Okay, what's the p-value then, Ben?
0.689.
All right. everybody there? They got number 6 then?
Nope. Hang on just a second.
And essentially, it's just the same thing. You plug in that information into that chart,
Right.
and then you just got to pay attention and make sure that you have the 0.95 in there, and then whether it's equal to, greater, or lesser than, and then make sure you have your n, your proper n value in there, the sample size, whatever it is, and so.
Okay.
So number 5 again. Sorry, I was
Number 5. Number 5 is 0.407. Number 6 is 0.689.
Okay, that gave me a chance to. Now, see, the thing is, we could put. Do we for sure like subtract the one from the other? Does it matter which one we subtract? Because sometimes he would say it really didn't matter. Which way we subtracted it?
I think it's
Apparently
if you're are you talking about, hold on, let me see, let me pull it up here. Are you talking about the confidence interval, like
different? So you gotta get on this one, the paired sample, you've got to take the difference too. So you calculate the difference, subtracting what the second one from the first one, or the first one from the second one column, and then you get that, and then you copy it all and paste it into the paired sample. So I'm saying is you had to read it through and make sure we subtracted which from which, right? Because it could be the negative 0.407 or it could be 0.407.
Yeah, if you're using, oh, hold on, let me see here.
You see what I'm getting at?
Get to the chart you're on. Version 10. Oh, okay, is it back this way?
So you get that chapter 12 data A.
Yeah, if you put it in the paired sampling, it'll just have the difference right there on the right, like the variable 1 and variable 2.
So if you put the 2 in there, the difference pops up automatically?
Yeah, it'll pop up automatically on the right there. It'll show you the differences. Yeah.
Okay, I just thought I had to calculate the difference as well. No, I don't have. Okay.
No.
Okay. Well,
but yeah, it works that way. So like in the sample, like if you have, I have 1, 7, 3, 5, 6. So in the top one, I have 1 and 4. So it'd be 1 minus 4 is -3. So yeah, it's left to right. And
left to right. Okay. Because I know sometimes it would be, it wouldn't be that way, but I got you.
Right.
All right. Okay. So I just won't calculate prior. I'll just copy those 2 columns and let it calculate for me. Okay. All right. So you said number 6 was 0.689. Jeff, did you get that?
I haven't yet. 0.689. Okay. Well, I'm close.
Rod and Roman, everybody got it? Are we all here?
Yeah, I'm good to go.
Okay.
Yeah, I'm good.
Okay, so we're on 7 now?
Yeah.
What's the correct decision based on this evidence? So we need to know if this point of...
It's above, so it's failed to reject.
So it's failed to reject. Okay, failed to reject. Everybody got that? Number 7 is failed to reject?
Yep.
Okay. Okay, number 8. Suppose your alternative hypothesis is instead greater than 0. What is the correct decision based on this evidence? Do we have to actually go in there and change it to greater than?
Yeah, you'd go in and change it greater than 0.
And then at this point,
it's B. We have insufficient evidence that the mean of differences is greater than 0.
Okay, thank you. We have insufficient evidence at the mean. Okay. All right, everybody got that? B?
Yep, good.
Okay, all right. Okay, so now we have the B1 data that we can plug in. What is greater? It's...
What I'll do is I'll be quiet until you ask me for the answer.
Okay,
if you guys want to plug it in and try to figure it out, and then I'll just tell you.
Okay, so I'll plug it in real quick.
Okay,
so
go ahead.
The other one, yeah, okay. This one I'm not going to calculate anything first. No, okay, so mine didn't calculate a difference. Should it, or should I go ahead and just have to put in the equation? Then did you take yours, the variable 2 minus, or variable 1 minus variable 2?
Well, let me look at the chart to look back. I'm also looking at my notes here.
Okay.
Let me look just real quick.
Mhm. Okay. So,
Chapter 12 to B1. I have these in my downloads. Oh well, I'll download it again. Yeah, I got it again. Yeah, I believe you just put it in the. You put that in the paired sample test, and you just compare.
okay, so I have which is at the end of the. Okay, so let me see what I got. So the N is the 22 is the and the DF is 21. So the 21 is the
So
DF is greater as the N is 22, right?
It's always greater. You get the other one by minusing one from N.
Mm-hmm.
you're right.
Okay, well that was done then.
Maybe a little math.
Okay, so N it will always be greater then. Okay, so N's greater. So the p-value would be 0.958, or we actually
001.
0.0012.
what am I?
Round to 3 decimals. Yeah.
The p-value?
Uh-huh.
So it's 0.001. Is that what we're rounding to then?
Yes.
Okay, wait, 0.001. I don't know what I'm looking at.
I'm going to share my screen again with you.
Okay.
Did you change this
Oh,
stuff here?
no,
0.990.
No, I did not.
P-value.
Okay, let me change it. So we changed it to 0.99 as well? Or does that matter?
Yeah.
But we put not equal to, and that's where I failed to. No.
I think it's still a 0.95 confidence level.
Yeah,
right?
but I don't have it right. I just plugged these in and I got all my everything else. I don't know what I did.
My screen looks similar to Rodney's. I know that. So
Oh my gosh. Okay, hold on. Hold on, let me do something real quick and then I will. Okay, well, that was the problems. I subtracted mine opposite, and that's why I did it. Okay, sorry. I got it now.
Okay.
I just wanted to make sure I did it.
Oh, yeah, I hear you.
Okay, so the p-value is 0.001, and our level of significance is 0.01, so it's less than, so we would reject the null, wouldn't we?
Yes.
Yeah.
Okay.
Yep.
Okay, so you try another alternative. This time you say it's greater than. So this is where we want to change it to greater than, right? And it actually is even less.
Decreased?
It decreased, right?
Yes. Decrease.
I think so.
Okay, what decision you may make? Well, we're going to still reject the null, right?
Yes.
Okay. Everybody good? We're at 13, reject the null?
Yeah, I'm good.
Okay. Okay, based on response from the previous question, what conclusion do you make? Okay, Ben, what was your answer now? Because I'm...
It is not A. I know that.
Oh, okay. That's as far as you got? There's no difference?
So this one I kind of got lost in.
Yeah.
I think it's C.
You say B?
We have,
C.
huh?
C?
We have sufficient evidence that there is a mean difference between the two groups. Okay,
What'd you say, Rodney? Did you say C?
Yes.
Okay.
see?
All right. Yes, there's a mean
So we're
difference
not even
between
going
the
to
two
ask
groups.
why. We have sufficient
Yeah.
evidence that there is a mean difference between the two groups.
Sounds good to me.
Okay, I'm good. I'm going to go on with that, Rodney.
Mhm.
Okay, so on that 15, which one will give you the smallest p-value? So the p-value decreases when would be the greater than then? I don't know. We definitely went down when we switched it from the not equal to greater than, correct?
Yeah, I got this one wrong too. So
Okay, so what did you pick? So we'll eliminate that one.
it is not D.
Oh, okay, it's not D, but we know it's not A either, right? Because well, let me do less than on the one we have in there then. See if it goes down even farther.
I think it's C. I don't think we have enough information.
It's C. Yeah, it's got to be C then because it's less than goes up. So it's got to be C.
Mm-hmm.
Okay, does everybody agree that it's C?
I'm good.
You're good?
I'm with Roman on this one.
Yeah, because it does go way down and go less than vice versa.
Well, I just changed it in the one that we had, and
like 0006 or something.
yeah, and the obvious answer would have been the greater than. And if it's not that, it has to be not enough because the other ones go up, right? So it has to be that one. Okay, so it says on this one, determine the 95 percentile confidence interval for the mean difference between the two groups using group 1 minus group 2. Huh? I mean, on the two spreadsheets that we had? What are you doing?
On 16, I got 11.955.
I have no clue how you got that. But
I'm not sure what, I don't know even know what we were doing. And what are we subtracting? The difference between.
What is the point estimate for this 95 confidence interval?
But what two groups? You mean the two spreadsheets we had opened?
It's referring back to the other one. Yeah, to.
Which one?
So determine the 95 confidence interval for the difference between the two groups using group 1 and minus group 2. So back up to, where is it? Going to it now. To the one right before 9. Use the data, chapter 12, the B1 data.
The B1, right?
Yeah, so that's the B1. So
okay. Okay, so I'm sorry. What did you get again, Ben? Because I'm just going to go with what you said.
11.955.
955. Okay.
I was good all the way up to this question. I have to go back and calculate that one. We don't have to do it in this moment. I can go back.
Right. That's what I figured.
Otherwise, I was right with you the whole time. So.
95. Yeah, I guess I just with the mean difference. So we get the difference between the two means. We take the two means and then we take the difference. So those two means, like we take the difference of the one, we take the difference of the other, and then we would take the difference of those two. That's what they did, right? So we'd almost plug in the two differences and then put that in a paired, I think. Yeah, I think I kind of know what they did, but I can't get that stuff. Okay, do you guys want to move on then? And I'll just, because I'll go back and just figure this one out later.
That's cool.
Okay,
yeah, either
so
way, yeah.
What is the margin of error between the two then, Ben?
This one I struggled on. My guess was 3.199. And that was so wrong.
Okay, so that's not right. Okay, so yeah. I could just I guess, okay, hold on. Let me plug these in really quick. All right, well, I'm just going to see what.
Well, I see the next two answers are the same thing. The upper bound and the lower bound as well are all going to have to be calculated. So.
Okay, so, shoot.
Unless Ben got them completely right with the wrong answer on the third one.
With what? Which one? What are you talking about? For 18 and 19?
Yes.
18 and 19 are right, which is weird because I'm like, okay, so how did I get the lower and the upper? And I got that wrong. So it's like, because I inputted the numbers it was all the numbers, but it's just like, and that's what I struggled with Wednesday stuff too as well. It's like some of the numbers are right, but like some of it is just like, I don't know, way off.
Right.
So I don't know. Maybe perhaps I didn't have the right confidence level in there or something, or it was greater or less than or something. But I mean, I checked everything and I tried to, but.
Right.
Okay, well, I'm just going to plug these in really quick and see if I'm figuring it out what I'm assuming that they're talking about. Okay. Shoot, I keep doing that. I'll make.
Yeah, if you're looking, when you get your numbers in.
Okay, so I got them in now. Let me just see if I did it the correct way. So let me go back up to the one above this.
Right.
11.955 for.
Yeah, I got 5.303 for my lower and 18.607 for my upper. And so just that way you can kind of look at those and see like, okay, did I re-input the right information?
Confidence intervals. So did we just take? So
I think the margin of error, I think it has something to do with like the 5%. I think so. You go into your T, your student T, and okay, so you put in, so you highlight the middle, right? I think. Hold on, I'm not sure if this is going to be right here. So 0.95. Okay, click off to the side, and then now you just need to make sure the degrees of freedom are in there, right? So what's our degrees of freedom? What's our test? Back up to the top, and just confirm with you, Rodney. So, and I don't see N there. Do you? Do you have an N? You guys see?
yeah. What do you mean?
The population group. Or
N is 22, isn't it?
Is it? Okay. So if it's 22, then you minus 1, and then you'd put 21, right? Is that correct, Rodney?
Yeah, I think so.
Okay, so I'll see if I'll put in 21, and I'll see what that does. So I'll put in 21 for the
okay, right.
21, and then now you highlight the outside, the tails, and then it should be 0.0466. So I guess don't take my word, but then it would be 0.47, 0.047. Because if you think about it, you put in the 0.95, right? So what's the margin of error? So it's the rest. It's the 5%. So you wouldn't highlight the middle, which is the 0.9.
Right. Just on the
highlight
outsides.
the outsides.
Yeah. Right.
And then you just make sure you have your degrees of freedom, which would be N was 22, so you minus the 1, and it's 21. So that's 0.047 would be my guess, but I don't know. If you guys have something better, then by all means.
Yeah, because I
this is my second guess. So
dealing with trying to find the margin error, that was a few chapters ago, right?
I think so. Yeah, he touches on it like on the video in the video.
I can't.
Or the Monday stuff he did, and I think last week he kind of every week at least the past 2 or 3 weeks he always has a little something on it or whatever.
I had the formula in my notes, but I don't have my notes with me.
Yeah,
but
hold on.
It's. I think you're supposed to plug it into the normal probability applet, the 0.95. Highlight the middle.
Z times
like 1.97 or something. Is the
1.96. You're talking about the actual
95% confidence.
Yeah, the 95% confidence level. Right.
Okay, so the M, like remember that little thing that he put in parentheses, M, the margin of error, I guess.
Yeah.
So if you're referring to that one was Z times the standard deviation divided by the square root of N. So that was that. That was the margin of error. So
Yeah.
if it's that, we can plug it in. We can check. I'm all down for that if you want to go for that. So you need to have your Z-score. So if you plug in 95 up there and you have that highlighted in the middle. Okay, so if you said in the normal probability app, right, Roman?
Yeah.
Okay, so we would highlight the center, unhighlight the outsides, put 0.95, and that would be 0.960. So that's our Z-score. So now we just need the standard deviation and the N, which is 22. So 22, I'll just tell you right now. I'll plug it in so you can copy and paste, so you don't have to.
And the standard, yeah. Well, it's all.
Yeah.
Is 15.003.
Yeah, and then the square root of 22 is 4.69041157598. A bunch of other stuff. Yeah, you wouldn't use the fish. That's the level of significance.
What was the Z-score for that?
Z-score for the normal app for a 95 is it's negative. Well, I don't know if you want the negative 0.90 on the left side or if you want the 1.960. I don't know. I don't know if you use the left or right on that.
I'm not sure. Was it 1.960?
Yeah, 1.960. Yes.
And let's see. So that's 0.626 or 0.627 was the formula. So the Z times the standard deviation divided by square root of N, and then we have to subtract that from X.
Actually, no. If you just want the margin of error, I think it's just that, because if you remember back in his video, it's just he put brackets around that, so that's just the margin of error. I think you just do Z times the standard deviation divided by the square root of N. That's it.
So the answer to question 17 is 0.627?
Oh, sure. Yeah, I'm down for that one.
Oh,
I hope it's right. If it's right, I'll give you a big. I want to see.
You said you got the lower bound and upper bound right?
Yeah, the upper bound and the lower are right. Yes.
Okay, what'd you get for the lower bound?
The lower bound. Let me get to it here. Where is it? Okay, here. Okay, so the lower bound is 5.303.
Okay.
And the upper is 18.607.
You got those right?
18.607.
You got those are right?
Yeah, those are right. Yes, the upper and the lower are correct.
What were we
Would
putting
the
in?
margin of error be the upper minus the lower divided by 2?
Sure. I remember something like that, because that's the thing. Like, and you do it different every time. You know, I catch bits and pieces, but I do remember, because I remember going over it, and then I was talking to my wife about it, and we did a problem like that. So let's do that. So you said minus the lower minus the upper divided by 2. You said, right?
The upper minus the lower divided by 2.
Yeah, but
Okay, the upper minus the lower. Okay, I'll try that.
for our margin of error?
Yeah, because the margin of error is just, that's how you find the lower and the upper.
Well, then our 0.267 isn't even close.
6.652.
Mm-hmm.
I don't know.
See, that's the thing, man. This is crazy. I mean, this seems like there's all sorts of different ways to do it, and it's just like,
I think that might be it.
which one? The 13.3?
Oh, the
Oh,
six-
divide. That's right. Divide by 2. I
Divide by 2.
So we died 2, then it's 6.652.
Okay, so you want to go with that one?
I'm thinking that's the right way to do it.
Okay, sounds good to me.
The upper minus the lower divided by 2.
Well, the thing is, you need the margin of error to find the lower and the upper bounds. But if you already have the lower and the upper bound, then margin of error is easy. You just do that.
Cool.
It was 6.652.
Yeah.
Mhm.
All right.
This is for question 17, right?
Yes, for 17.
0.65.
No. 6.652. 6.652.
In between the two. My God.
Cool. And that's the weird thing. It's just like,
20 out of 20.
yeah, 20 out of 20. You guys are the bomb.
I didn't even remember him doing it that way. I watched the videos and I don't remember him subtracting.
No, that's not how you do it because you need the margin of error to find those two numbers.
Yes.
You can't subtract the two numbers to find the margin of error because you need it first. But
Oh,
Ben already gave us the answers to the second two. So
Well, that would have been, if I would have known that, because once you plug in all those numbers into that quantitative table, you get the upper and the lower. It's just like, I should have just,
right.
maybe I should add a thing in there where it does the automatically. This is the margin of error off to the side and plug in that formula. That'd be sweet.
yeah.
Cool. All right. So go to submit. You guys rock. Okay. That's awesome.
All right,
Okay.
guys. Hey, I have a question for you guys for Wednesday night. Is there a way we can start a half an hour later? I'm so sorry. I know no one wants to, but
I would totally love that because I have to drive from Southern Iowa to Green Bay.
7:30. That's fine.
yeah, but is that okay? I have to be at the
Yeah, yeah,
church for a thing with the young women, so if that'd be okay. So
Yeah.
my time is 8:30.
8:30 Mountain.
8:30
Yeah.
Mountain.
7:30.
Yeah.
Yeah, is that okay? Okay. Do you want me to
Totally.
record it again, or I'll just do the full? Let me just complete the week.
Yeah,
then
and I can do next week if no one else wants to do it. So.
Okay. Okay, so I'll just do it, but I'll start it a half an hour later if we're good.
Okay. 8:30
Hey,
Mountain.
Thank you guys so much.
Cool. And then hopefully we'll get the same thing. I got a C on Wednesday stuff, so I need to do better.
Okay.
Oh my gosh. But maybe going through this stuff with you guys, I'll go back. I took screenshots and I'll go back through and try to figure out the stuff and maybe I'll have the right answers. So,
All right.
so cool.